And do you want us to turn in my notes that we took with those?
They can be turned in today. Let's see. I've been carrying these around for I don't know how long. These are those okay. Let's see.
See one more. Maybe we'll go today.
Okay, folks. First of all, as of this morning, all the videos that the Zoom lectures have been either uploaded or are uploading. It sometimes takes a little bit of time, but they are in the process. So the only one that I'll need to upload after class today is the one from today. Otherwise, all of them for this exam have now been uploaded if you need to go back and watch the lecture videos. You requested, and I sort of complied again. I have an old study guide. Now, I have not posted the answer key to the study guide yet because I got to go and check the answers. But I do have a study guide that you can work on for the test that is on Tuesday. I'm missing 2 people. So I will try to get to my office in the next, or once I go back to my office, I'll try to look at the answer key and determine if the answer key is correct. And if so, I will post it. Like last time, there will be 2 answer keys because this study guide actually is a compilation of 2 study guides that I've used in the past. So you'll see that one of them, it just says Introduction to Organic and Biochemistry. That was exam 2 study guide. And exam 3 is the study exam test 3. So, again, I plan to go to my office and post the answer keys. I just have not gotten them. I have not reviewed it yet to see if it's accurate. So I will be doing 2 things once I get back to my office, uploading the video from as soon as it's available from today, and then providing the answer keys to the study guide. Just as a reminder, you have a homework from Tuesday and you will have a homework from today. That will be the 3rd thing I'm going to be doing. And those homeworks are due on Monday at 11:59 p.m. Also on Monday, your reactions lab is due. It will be due during the lab. Your egg lab from this week is due. Again, it will be due during the lab. And in lab, we will be doing the carbohydrate lab. The carbohydrate lab, because it is a dry lab, we will meet in Mannion 105 on Monday. And then exam 2 is on Tuesday. So any questions about when things are due, what's coming up through the next little bit? Okay. So today, my goal is to discuss the acidity of carboxylic acids, which I started introducing on Tuesday. We will then deal with the reaction of carboxylic acids with a strong base, and we will learn how to name the salt that arises. We will then get into esterification, amide formation, and hydrolysis. And if time permits, I will do the phosphoric acid derivatives. But I don't know whether time will permit in relationship to those. Any questions? Okay. If you did the extra credit Zoom and you took notes before you leave today, please turn those notes in. And I know who attended, so if you just attended, you'll get your 5 points because I can look up who attended. But if you took notes, I'll need those notes in order for you to get the other 5 points. Other questions? Okay, so on Tuesday, we talked about the fact that if we have a carboxylic acid, and just to keep things simple, I used acetic acid, though we could use any carboxylic acid, and we added that to water. The carboxylic acid would act as a weak acid. It would donate its acidic proton to the water to make hydronium plus the anion of the acid. We can build a Ka expression for this. It would be equal to the products over the reactants. And the Ka comes out to be a number in scientific notation. Because it is more difficult to readily look at a number in scientific notation and understand what you're working with, instead of working with the Ka, we typically talk in terms of pKa. And just like pH is equal to the negative log of the hydronium, pOH is equal to the negative log of the hydroxide. If we have the pKa, it's equal to the negative log of the Ka. Now, with the pKa, the smaller the number, the more acidic the acid. Now, for most carboxylic acids, they range around the same. They're in a range that's fairly close to that of acetic acid. So the majority of your carboxylic acids are going to be in that range of about 4.7. There are some exceptions to that, like trichloroacetic acid. Trichloroacetic acid, due to the electronegativity of those chlorines, makes it a much stronger acid. In fact, the trichloroacetic acid is on the same order as sulfuric acid. So it's a pretty nasty material. But the majority of carboxylic acids are going to range around the acetic acids, pKa. If you do have a dicarboxylic acid, such as oxalic acid and malonic acid, it's really the first pKa that is of interest to us, because the second dissociation is going to be a lot harder. So it's really that first pKa that is important to us. So again, these carboxylic acids tend to act like an acid. So if we were to take these carboxylic acids, we could react them with water, as I did previously, or we could react them with a base. If we react them with a base, such as sodium hydroxide, then what we form is an anion of the acid that is attracted to the cation of the base plus water. Now this, because it is an ionic compound, it is called a salt. And salts are named using the cation followed by the name of the anion. So this particular salt up here, the cation is sodium. And the anion, now this anion you probably should already know the name of, because it is a polyatomic ion that is frequently used, and this would be acetate. I like to use this particular example because you will notice My iPad's freezing. The anion is named the same way as the parent of an ester. Because if you'll remember, the parent of an ester, we would take the ic acid or the oic acid off, and we would replace it with 8. We do the same thing. We took the ic acid off of acetic acid, and we replaced it with 8. So if I were to take benzoic acid and react that with sodium hydroxide, I would get a negatively charged ion that is attracted to the sodium ion and water. The acid was benzoic acid. So this salt over here, we're going to name it with the cation first. Cations always go first. And then we're going to name the anion, but we're going to name it like we would have a ester. So this would have been called benzoate. Now, I'm using sodium hydroxide, but you could use any strong base. So really what we're dealing with here is a carboxylic acid plus a strong base goes to make a salt plus water. That's the reaction. I've used sodium hydroxide because it's a common base. Potassium hydroxide would also work. In fact, the salts of sodium ions and potassium ions are much more soluble than the acid itself. But again, it doesn't have to be sodium hydroxide. It can be another base. It just needs to be a strong base. Questions? So just so that you get a little bit of practice, I want you to take 2,2-dimethyl pentanoic acid and react that with potassium hydroxide. And I want to know what are the products, and I want you to name the salt. Yes.
If it was a cyclic, you would say dimethyl cyclopentanoic acid.
Correct.
Okay. Just name it.
I still have to include the word cyclo to let you know it's cyclic. Yes.
With the earlier example of the sodium acetate, on the test, if we were like naming it, would it would we also be able to do sodium ethanoate?
Technically, yes.
Because active was making us do the ethanoate, propanoate.
Yeah, technically, yes.
Oh, okay.
Simply because that would be the IUPAC naming of it,
right,
rather than the common name.
Oh.
So if you give me ethanoate, unless I specify IUPAC or common, then if you were to give me sodium ethanoate, it would be correct. Sodium propanoate. That's just what that is doing, is using IUPAC naming.
Right.
Rather than common naming. And with carboxylic acids, I mean, I get it because it if I recall on those, it did specify the IUPAC naming.
Right.
But you're going to see the common name more often typically. But like I said, I believe it specified IUPAC on active.
It did. I was just wondering on the test.
If you give me either one, that's correct, unless I specify IUPAC or common.
Okay, gotcha.
Okay, so the first thing I have to do is I have to figure out what this thing is. So it's pentanoic acid. So that's 5 carbons with a carboxylic acid on the end. Carbon 1 is going to be the carboxylic acid carbon. So carbon 2 is going to be where I have my 2 methyl groups. So that should be the structure. Or you could have written it out as CH3, CH2, CH2, CH3, CH3, C double bond O, OH, whichever works best for you. And if you do it with KOH, then the main product that we're looking at is CH3, CH2, CH2, C, CH3, CH3, C double bond O, O minus, with the potassium in this case as our cation, and then our secondary product is water. Now to name this, it would be, you would name the cation first. So this would be potassium. Then you would name the anion, which in this case, we would have to call it 2,2-dimethyl pentanoate. Because we replaced the ic acid or oic acid with 8 on the anion.
You could have called it
Valeric acid. If this is valeric acid, then yes, you could call it valerate. Okay. So, if that's the common name for this stuff, it's easier when they give you the name just to rewrite the name.
Right.
But
I just want to make sure.
This would be IUPAC naming.
So when do we want to say 08? And when do we want to say just 8?
A lot of times you put the 08. If it would have had the oic acid, we usually do 08. We replace the ic primarily. If we replace the IC with 8, then that would be the same.
I think acetic acid is like one of the main.
It's one of the main exceptions for everything.
Right.
But typically, if it was an oic acid, it's an 08. Just to make it roll. Questions? Okay. So that was the carboxylic acids. We have spent a lot of time on the carboxylic acids themselves. And then we've talked about how to name esters and name amides, but we've spent a lot of time on the carboxylic acids. Now what we're going to do is we are going to specifically get into the reactions of the carboxylic acids to make the esters and the amides. So
the range that you mentioned with the pKa, what is that range from 1 to 4.7?
They actually range on up. So you can get, I mean, the textbook only gives you a small portion of the various pKas, and the pKas that it gave range from 0 to 5.5. Basically, and if it's an acid, you got to think back. pH, what would be the most common pH if it's an acid? What would be the pH?
4, 1, 2.
Anything below 7.
Okay.
The same thing goes with these pKas. Most of them are going to be below that 7 mark. Most of them are going to be within 1 to 5.
Okay.
But not all. I refuse to say all on anything because there's going to be exceptions to every rule. Okay, so we've talked about the fact that carboxylic acids react to form esters. And the process that occurs is called, to make that, is esterification. Esters are an extremely important set of compounds. If you ever use flavorings like banana flavoring for something, or peppermint flavoring like for gum, or even the smell that comes off of some beers, what you're smelling is an ester. Most esters smell good. There are some that don't, but a lot of them smell good. So esters are an extremely important part of our daily lives. Esters are also an extremely important biologically, because esterification is the process by which lipids are made. So, let's talk about esterification and how to make an ester. Basically, what you're going to do is you are going to take a carboxylic acid, in the presence of an alcohol, and that is going to, and usually an acid catalyst, and that is going to wind up producing an ester as one of its products, and water. So if I take benzoic acid and I react it with ethanol, with an acid catalyst, I am going to make the ester. Now, the way this ester is made is that the oxygen from the alcohol attacks the carbonyl carbon. It temporarily kicks the electrons in the double bond up onto the oxygen in the carbonyl group, but that is temporary. Those electrons then come back What are you doing? Leave it alone. Those electrons then come back to form the double bond and ultimately kick off the OH group. The resultant product from this process is going to be the benzo. You're going to take the benzoic acid. You're going to make the ester bond with the ethyl group. And then you'll make water. This is to name it. We have already talked about the process of naming. You start with the alkyl group. So that is ethyl. And then you name the anion of the acid. So that is going to be benzoate. If I take oxalic acid, and I react it with two equivalencies of methanol in the presence of an acid. Yes.
If you know what that problem, can you go back up to the previous one and like walk us through it again? Because like I think it went a little fast. So can you like explain it again?
Yes, I'm actually doing the exact same process on this one. I'm just using a different acid. So I was going to do 2 or 3 of them, and maybe the process would make sense. Okay, so again, the OH group attacks at the carbonyl carbon. It temporarily kicks up the electrons in the double bond onto the oxygen. Those electrons then fall back to the double bond, ultimately kicking off the OH group. Now, because I have 2 equivalencies of this, let's see, we're going to highlight 2 equivalencies. This process occurs twice. It occurs once with the carboxylic acid on the right-hand side of the oxalic acid, but the second one would occur where it reacts with the carbonyl oxygen, kicking up the lone pair from the double bond onto the oxygen, which then tumbles back down and kicks out the hydroxide group. So when you get done with this, you would have a methyl group attached to an oxygen, attached to a carbonyl, attached to another carbonyl, attached to an oxygen, attached to a methyl group for your product, and you would have water. Because I am dealing with oxalic acid and the you got to remember, carboxylic acids have to be on the end. They're never in the middle of the compound. They're always on the end. Because of that, I don't have to specify the locations of the methyls. So this one would be called dimethyl oxalate. From oxalic acid is where the last piece comes from. I wanted to show a dicarboxylic acid because we haven't done too much of that work with that. But as long as there's a carboxylic acid group, a methyl group, alcohol can attack at the carboxylic acid. It's always going to be the alcohol attacking the carbonyl. The alcohol attacks the carbonyl. The alcohol attacks the carbonyl. It's always the alcohol attacks the carbonyl. In all cases, the electrons temporarily jump out of the double bond up onto the oxygen. So they temporarily jump out of the double bond up to the oxygen. But they always come back to reform that double bond. And when they come back to reform the double bond, because carbon can only have 4 bonds, it's going to kick off the hydroxide group.
Would there ever be an instance where the 2 is?
Yeah.
What now?
How do I say that?
Is there an instance where there will only be one alcohol acting and it will only do one carbon group instead of both?
That is always a potential.
Okay.
So you just pick one.
You just pick one. Okay. But because carboxylic acids are always on the end, unless there's an alkyl group in there somewhere, you're only going to have one product in this. In the case of dicarboxylic acid and malonic acid, you still only get one product. Only if you have an alkyl group off of a carbon in between, you would have to have an alkyl group off of a carbon in between the carbonyls in order for there to possibly be more than one product.
So if there was just one, we just do one right in one time.
Correct.
Okay.
If I hadn't put this 2 here, I could have only reacted it with one carbonyl.
Okay. That's good.
Did that answer your question? Yes. Okay. I was going to repeat the process one way or another, so I was just making sure. Okay. Folks, if you can do esterification, you could do amide formation. Because they go through the same process. But the only difference is, in the case of amide formation, you take a carboxylic acid in the presence of an amine. And the difference is that you use heat as a catalyst. And ultimately, that comes out as an amide and water. So let's take butyric acid. And react butyric acid with dimethylamine. We're going to react that in the presence of heat. The process is the same. The only difference is the heat, and then it is the nitrogen that attacks the carbonyl. When the nitrogen attacks the carbonyl, it kicks up the double bond, which then reforms. What in the heck? kicking off the hydroxide group.
They both would have an acid catalyst making no.
No, this one has heat for a catalyst. So the product of this one would be CH3, CH2, CH2, C double bond O, N, CH3 plus water. Naming it, we named these the other day. The first part is what's attached to the nitrogen. And so we have to name this one N,N-dimethyl because there are two methyl groups attached to the nitrogen. And then we name the carboxylic acid group with the ending amide. So this would be butamide or butyramide, because you take off the ic or oic acid and replace it with amide, butyramide. Yes.
So you are putting the NN because you do have to specify the methyl groups. Because when the other one you didn't have the NN. And it's because you said you don't have to specify methyls, right? Or do you have to specify where they are?
You for the dimethyl on the oxalate, that is correct, because the oxalic acid, the carboxylic acids are always on the end. But this wasn't attached to the carbons aren't attached to the carboxylic acid. So if you look at the previous one, the carbons are attached to the carboxylic acid group.
Yes.
In this one, they're actually attached to the nitrogen and not the carboxylic acid. So you have to be a bit more specific. Anytime you attach something to a nitrogen, a lot of times we use the NN. Folks, where does the water come from? That will help you in figuring out on all of these. Let's talk where the water came from. We'll go with green because I don't use green much. The water comes from the carboxylic acid. There's the OH for the water and the hydrogen off of the alcohol. Comes from the OH of the acid and the hydrogen of the alcohol. In this particular case, it comes from the OH of the acid and the hydrogen of the amine. That's where the rest of it comes from. That's why water is always a product. Yes.
For the example above, what happened with the other OH?
Technically, there's two waters. Whoops. Questions? Esterification and amide formation happen the same way. Esterification and amide formation happen the same way. The only difference in the formula besides the fact that one's an alcohol and one's an amine, the only other difference is what the catalyst has to be. In esterification, you got to have the acid catalyst. In amide formation, you have to have heat. Questions? So the next thing we're going to talk about is hydrolysis. Let me ask you a question before we even get into hydrolysis. When you hear hydro, hydrate, hydration, hydro, whatever, what do you think about? Water. Guess what we're adding with hydrolysis? We're adding water. So with a hydrolysis, what you do is you take an ester, you add water. Now, this has to occur in acid to make it happen. And the products are your carboxylic acid and the alcohol. I want you to take a moment and I want you to go back to esterification. I want you to look at esterification. Now I want you to look at hydrolysis and tell me what you see. Everything's identical, it's just in reverse. Everything is identical, it's just in reverse. Now, technically, so if I start out with an ester, such as, let's just keep it simple this time, CH3, C double bond O, O, CH3, and I react that with water in the presence of an acid, I'm going to get the original carboxylic acid back. Plus, I'm going to get my original alcohol back. If you go back to what we were doing, I think it was on Tuesday, and look at how I taught you to name an ester. I had you break the ester into its acid and its alcohol. In other words, when I was teaching you how to name an ester, we were doing hydrolysis. We just didn't call it hydrolysis. We didn't say we were adding water at that point, but that's what we were doing. Any questions about hydrolysis? Now, hydrolysis for an ester can occur two different ways. This is method number one. Method number two is we can take an ester in the presence of a strong base under with water. And instead of getting the carboxylic acid back, because we're using strong base, instead we're going to get salt and the alcohol. We actually were doing this a little bit earlier with the carboxylic acids and the salts. Now we're just doing the same thing with the esters and the salt, the strong base. So if I have, for example, let's go back to benzoic acid, another fairly straightforward, easy one. And let's make it an ester. And I react that with sodium hydroxide in the presence of water. Where it's going to cut is always going to be here. No matter what we're doing, we're cutting at that carbonyl carbon. The sodium and oxygen are going to go towards the carbonyl group, with the hydrogen going with the OCH3. So we get sodium benzoate and we get methanol. So again, there's two ways we can do hydrolysis with an ester. We can add the water by itself in the presence of an acid, and we're going to get out the carboxylic acid and the alcohol. But if we add the ester with the presence of water and a base, we're going to get out the salt and the alcohol. So the only difference between these two is, am I adding an acid or am I adding a base? If I add an acid, I get the carboxylic acid. Acid. If I add a base, I get the salt. Those are the two reactions of esters. Hydrolysis of an ester. There's two ways to do it. Depending upon the path you take, depends upon the primary product you get. The other product is going to be the same, but this primary product is going to be different. You can do hydrolysis on an amide. It's actually simpler. You take an amide in the presence of water, and it doesn't matter whether you use an acid or a base. Your product is going to be the same. It's going to be the carboxylic acid and the amine. again, for an amide, it's simpler. The process, the overall process is the same. Amide plus water, you break it up back into its original things. But it's simpler because this one doesn't matter whether you do it in acid or if you do it in base, you're going to get the same result. Whereas with an ester, it did matter whether you did it in an acid or a base. And it has to do, folks, why are these two different? Well, it has to do with the fact that an amine is a base. And so you're reacting an amide with water, and you're getting an acid and a base. You're getting but with alcohols, it's different. They're extremely weak acids. I mean, weaker than any other acid out there. So they don't readily do their thing. And so they need a little bit more shove. Questions? Let's look at some practice. Okay. Let's take raspberry oil is an ester formed from formic acid and 2-methyl 1-propanol. Write the reaction. And name the ester. You will be told if it's base catalyzed.
So since you didn't say whether it was in an acid or a base, it's automatic. You think it's
Acid catalyzed.
I think, okay, so on the product side, I think I'm understanding everything until we get to that first CH2, and then I'm lost.
Okay, so
What the formic acid?
okay, so you get, we're going to chop here and we're going to chop here. And we're going to slam them together. Because that's where the water comes from. So I literally took that carbonyl carbon, and the next thing in line was the oxygen, followed by the CH2, followed by the CH, CH3,
Gotcha.
CH3.
Gotcha. Okay.
Does that help? So sometimes it helps if you just squiggle down what you're chopping off to get the water, and then you combine the other two. Okay. And yes, this could be isobutyl or isobutyl formate.
That was my question.
That could be another way to name this one, isobutyl formate. My brain is trying to think also. So, okay. Let's look at another example. Draw the structure of the amide made from aniline, and draw better here. Cyclopentyl carboxylic acid. Let's see, cyclopentane, pentanoic acid. That's it. You're going to do the same thing I just described earlier. You're going to chop off the OH and one of the H's. And that would be your product. Plus water, technically. All these should be plus water. If it's forming an ester or forming a amide, add water as a product. Water is always one of the products. Questions about amide formation or ester formation?
Would the name of that one be N-phenol cyclopentamide or pentam?
Not phenol, because you don't have an, it's not the.
Oh, they're right, no OH.
So yes, it would be phenol.
Phenol, right.
So it'd be N-phenol. N-phenol cyclopentamide. Okay, so let's look at another example. Draw the products or the product of the acid catalyzed hydrolysis of you should have gotten out phenol and cyclopentanoic acid. Basically, it breaks this bond. It always breaks by the carbonyl. With you adding an OH, and because it was acid catalyzed, you add an OH to the carbonyl, and you add an H to the rest. Now, on the test, I'm not telling you hydrolysis. So how do I know what I'm doing? How do I know which way I'm going if I'm not telling you it's hydrolysis? If you start with an ester or an amide, it's probably hydrolysis. If you start with an ester or an amide, you're probably performing hydrolysis. That's how I know that it was hydrolysis that I was thinking of. That's one reason I took the time up here to actually write out words rather than write out just reactions. Because if I start with an ester or an amide, I'm doing some form of hydrolysis. If I start out with carboxylic acid, I'm either making a salt, an ester, or an amide. So it's dependent upon what you start with as to what type of reaction you're working with. Okay, I wanted to make 2 notes on the study sheet I gave you, because I did not get to phosphate esters, which I had a feeling I might not get to. It is going to be the one starting with the word study exam 3. And we'll actually be caught up. For the next one, I'll be able to just bring in the right one. Study exam 3. Cut number 2, because we didn't talk about that I had a question mark beside. And I forgot to put a question mark, but on page 7, D. You'll notice it has the phosphate group. That one needs to go as well. 7D. I didn't put a question mark beside it, but it needs to go as well. And any questions for me? I knew once we got past that first section where we were talking about all the different types of naming, it was going to go much quicker because I was already doing a lot of the reactions when we were doing the naming. It was just, I hadn't put words to them. Now I've put words to them. Questions for me. So I will be doing 3 things. I will be posting the video from today as soon as it's available. I will be checking the exam key and making sure it's correct before I post it. And I will be posting a homework over this information. Any questions? If not, I will see you Monday in room 105 for a laboratory lecture type thing.
Yes. So I draw in like this way, which is opposite